In this video, we'll be talking about measurements in triangles and focus majorly on the area of triangles because perimeter is just adding the length of all the three sides. Now, these are various ways we could see triangles. Now, the most popular formula for area of a triangle is half base times height. So that is half base times height. So the base is that side from which the height we are taking note of is at right angles to. So this is the base. If this side was given and then we needed maybe another height, then this should now be the height. The height must be in perpendicular to the side of the triangle we call the base. Okay, so this is the height for this and this is the base, yeah. For this other triangle, this is of course the height, and therefore this is the base and this is the height. So still half base times height. Now for this other triangle, if we are going to take this place as the base, then this is the height. This is the height for this triangle. The height is always perpendicular to that line we call the base. Okay, so this is the most popular formula for area of a triangle. Now, what if two sides of that triangle and an included angle is given? Then its area becomes half. Now, let's now, so as to avoid confusing ourselves, let's call this place A. Let's say that this angle was given. This angle theta was given. And then let's say this is A, B, and then of course C. So an included angle. So half A, B, sine theta. Then for this is side B. Let's say this is the angle, for example. The angle can be at any point, but let it be an included angle. And let's say this side is side A. So still the same thing, half AB sine theta. That is, A is one side, B is another side, and theta is an included angle. Now, what if all the three sides were to be given? No included angle, no height. So it becomes, we use a formula, a special formula we call Hero's formula. Okay, in that formula we have that area is equal to the square root of a value we will call S. So this is side C, this is side C. Okay, so a value we call S minus side A, S minus side B, S minus side C, all multiplying each other, where S is equal to half of the perimeter, so half A plus B plus C. Okay, so we'll now be looking into examples whereby we apply these different formulas at different cases. Now we have this question, this diagram here, and we've been asked to find the area of triangle XYZ, so the area of the whole triangle. Now we have height, but we don't have the base. Remember, the height must be perpendicular to the side of the triangle we call the base. So here we have 8 cm, but we don't know the length of KZ so as to complete our base. So half base times height. Therefore, we are going to look for this side. And we can see this is at this perpendicular line. So this part of the triangle is a right-angled triangle. And we can use Pythagoras theorem to find this point. So this side is the hypotenuse, right? So we have that hypotenuse squared is equal to this side squared, 15 squared, plus, let me call this point, let me call this point x, small letter x squared. Now to make x the subject of the formula, we have that x squared is equal to 25 squared minus 15 squared. Now, let's just solve this without a calculator. So this is the difference of two squares. Remember, difference of two squares, 25 plus 15, 25 minus 15. Sometimes it's easier to handle calculations this way. 25 plus 15, that is 40, times 25 minus 15, that is 10. 40 times 10 is equal to 400. Remember, this 400 is equal to x squared, this side squared. So, x is equal to the square root of 400, in which you can further open up the sort to be 4 times 100. So, we know that the square root of that is 2 times 10, right? 20. This is unnecessary. This line is unnecessary. This part is unnecessary because we know that this is 20, but for other numbers, you could use this method of spreading it out to actually work without calculator. So we know that this part, x, is 20. Remember that it's the area of the whole triangle. So this is 8, and we now know that this is 20 cm. Okay, so what we have to do is to now say half base times half base, which is 28, times height, which is 15. So area of triangle XYZ is equal to half base is 28 cm, times height, which is 15 cm, which is equal to half of 28 is 14 times 15. And when we punch that, we have that it is equal to 210 cm squared. Area is in units squared. Okay, now looking at this triangle, we have this shape and we have that this shaded portion, triangle EGH, that the area of triangle EGH is equal to 40 cm squared. And we've been asked to find the area of triangle EFG. That's the area of this part. Okay, to solve this, we are going to start from the known to the unknown. Now, this 8 cm, this part 8 cm, is the height of triangle EFG and also the height of triangle EGH. We saw that at the beginning. Okay, so we are going to equate the area of this part of the triangle, of this triangle that we know, so as to find what x is, because that is what is preventing us from finding the area of triangle EFG. That is half base times height. So we know that this is the base of this triangle, right? And this is the height of this triangle EGH. We have that 40 cm squared is equal to half base, and the base in this case is x plus 2 cm times height, which is 8. So we can, this is multiplication, so these two can cancel out, giving us 4 here, and we divide both sides by 4. Okay, let me take that to another line of solving. So we have 40 divided by 4 is equal to x plus 2. So, in which finally we have that 40 divided by 4 is 10. So, x plus 2 is equal to 10. Therefore, x is equal to 10 minus 2, that is 8 cm. So we know that x is 8 cm. Simple. So the area of triangle EFG, is now equal to half base. Base is 8 and the height is also 8, which is 8 times 8, 64. Half of 64 is 32, or you say half of 8 is 4. 4 times 8 is 32 cm squared. Area is in cm squared. Okay, so here we have this. We are told that the area of this triangle is 21 root 3 cm squared. So we are to find the angle. Remember that one of the formulas for a triangle is half of this side times this side sine theta. So half product of two sides given sine the included angle. So that is what we are going to use. That this, okay, that is half of 7 times 12 sine theta is equal to the area given is 21 root 3. Okay, so we are going to now use this to find what theta is. That's the angle given. So we have that half, that is 6, 7 times 6 is 42. Or we just say sine theta is equal to 21 root 3 over 7 times 6 comes here to be as division, 7 times 6. So 7 into this is 1, 7 into 21 is 3. And 3 and 6 can divide each other. So 3 here is 1, 3 into this is 2. So all we have left is that sine theta is equal to root 3 over 2. And by now, we already know how to get the common angles, trigonometric ratios with our fingers, right? So sine is number of fingers, square root of number of fingers below over 2. So this is root 3 over 2. So we are going to say, so that is 3 fingers below, root of 3 fingers below over 2, right? So remember that this is angle 0, 30, 45, 60, and 90. So since it is root 3, so that is this. So meaning that our angle is this. So 60 angle 60. We have, therefore, so this is just working without calculator. Therefore, theta is equal to 60 degrees. Or you can remember this common angle whereby we have this is 60, this is root 3, this is 2, and this is 1, and this is 30 degrees. So whichever way you remember it from, then you know that this root 3 over 2 is actually equal to 60 degrees. So we have made use of this formula for area of triangles. Find the area of a triangle whose lengths are 3 cm, 4 cm, and 5 cm. Okay, so for this triangle, we've been given the three sides. Now is an opportunity for us to use the hero's formula. Okay, so we are going to write it out. So we are going to say, so this is sides A, B, C, right? So the hero's formula says that the area of a triangle is equal to the square root of a value we called S, which is half of the perimeter, into S minus one of the sides, into S minus the other side, into S minus the third side. So this is equal to area of the triangle. Now we are going to get what S is. S is half of the perimeter. So S is equal to half of 3 plus 4 plus 5. 3 plus 4 plus 5, that is 9, plus 3, that is 12. So we have half of 12 is 6. So S is equal to 6 cm. Now we substitute into the hero's formula. We have that the area is equal to, we have S, which is 6, into 6 minus 3, 6 minus 4, 6 minus 5. You could see it's easy. It looks kind of complicated here, but it's actually easy. It's easy to remember. Okay, we bring down 6. 6 minus 3 is equal to 3. 6 minus 4 is equal to 2. 6 minus 5 is equal to 1. So we have 1 times 2 is 2, 2 times 3 is 6, 6 times 6 is 36. Or we could just leave it as just 6 times 6, in which we just know that the value for the square root is equal to 6 cm squared. So the area of this triangle given is 6 cm squared. Always remember that area is in units squared. Okay, let's look at this other unique question. The areas of two similar triangles are in the ratio of 3:5. If the area of the smaller triangle is 45 cm squared, what is the area of the bigger triangle? Now, we know from similar shapes that if it is lengths, so we have that the ratio is 3:5, so bigger over smaller. And if it's lengths, all about lengths, we have to compare it to this. But since this is area, this ratio has to be compared with a square of the ratio, because area is a length times another length. So the ratio has to also be squared. If it were to be volume, it has to be the cube of the ratio. So this, or we just separate it into 3 square over 5 square, is equal to the smaller triangle is 45 cm squared, right? So 45 over the bigger triangle, let's call that x. So this represents the area of the bigger triangle. So we are going to make the area of the bigger triangle, which we represent by x, to be the subject formula. So x is equal to 45 times 5 squared, so that's cross multiplying. We have 45 times 5 squared over. Now, by the time we cross multiply, we have that 3 squared times x is equal to 45 times 5 squared, right? So at the end of the day, we divide both sides by 3 squared, which is 9. Is that okay now? So we divide by 9. 9 into itself is 1. 9 into 45 is 5. 5 times 5 squared, that is 5 times 25, is equal to 125. So this is area, it's in units squared. Okay, so you see, as simple as that is.